Dear students, for today we'll see some multiple choice questions on semiconductor electronics, which will be useful for competitive exams like JEE, NEET, CET. So let's start with the first question of the third part, question number 21. In VI characteristics of PN junction, reverse biasing results in. The options are leakage current, the current barrier across junction increases, no flow of current, and large current. Now we know whenever a PN junction is reverse biased. So if you see a PN junction, say this is P type of semiconductor, which is having majority charge carriers as holes, and this is N type of semiconductor, which is having majority charge carriers as electrons. Now these, when they are a reverse bias, so we have a depletion layer which is of a larger size. So here we can see this is reverse bias, and we call it as reverse bias because negative terminal of the battery is connected to p-type semiconductor and positive terminal of the battery is connected to n-type semiconductor. So holes are attracted here and electrons are attracted here. Okay, now this is the depletion region which forms, and the depletion area will be more. Okay, now in this, the flow of current which takes place is because of the minority carriers. Now what are minority carriers? In p-type semiconductor there are a few electrons which arise because of rise in temperature, and because of that covalent bond breaks, and so we get a few electrons. Similarly, in n-type semiconductor, we get a few holes which are called as minority charge carriers. Now, these minority charge carriers are there because of rise in temperature, and because rise in temperature, we have some covalent bond breaking, and because of that, these electrons and holes come into picture. Now, for these minority charge carriers on either side, the polarity of the voltage applied behaves like a forward bias. Like for example, here we have few electrons, and for them this negative is going to act as forward biased. Similarly, we are having some holes here, so this positive terminal of the battery is going to act as forward bias. So these minority charge carriers, now after some increase in voltage, start crossing this barrier. They start crossing the barrier. Now this is a reverse current which is flowing, and this reverse current is because of minority charge carriers, and this reverse current is also called as leakage current, and therefore here option A will be the right answer. In VI characteristics of a PN junction, reverse biasing results in leakage current. So here leakage current is a name given to the reverse current, and here you can see option A is the correct answer. Then we'll go to the next question. Question number 22. In reverse biasing, option A says large amount of current flows. Option B says potential barrier across junction increases. Option C says depletion layer resistance increases. And option D says no current flows. Now, out of this, the thing which specifically happens first is, now whenever you are having this PN junction and that PN junction is reverse biased. So here we can show like this PN junction. This is P type of material and this is N type of material. So here you can say holes are the majority charge carriers. Here electrons are the majority charge carriers. And this is reverse bias. Reverse bias. So this is minus, this is plus, and here you see the depletion layer because the majority charge carriers are attracted towards the polarity of the battery, and the depletion layer here increases. There is no charge carrier which is going to cross the junction in the majority charge carriers. Okay, so therefore here in reverse biasing, specifically first what takes place is potential barrier across the junction increases. So the potential barrier across the junction increases, And because of this, the resistance of the depletion layer increases, and because of this, there will be no flow of majority current. Okay, so the specifically the first thing what happens in reverse biasing is option B, that is potential barrier across junction increases. So here we can see in the reverse biasing of PN junction, the voltage applied supports the barrier voltage across the junction, which increases the width of depletion layer and hence increases its resistance. So here option B will be the correct answer. Potential barrier across the junction increases. Then we'll go to the next question. Question number 23. Zener diode is used for what? Option A is amplification. Option B is rectification. Option C is stabilization. Option D is all of the above. So here we know that a Zener diode is always connected in reverse bias, and in reverse bias it keeps the input voltage constant at the output when it increases above a certain level. Say for example, if we are using a Zener diode of 6 volt breakdown, so then if the input voltage goes above 6 volt, the output voltage remains for 6 volt only. That means here the Zener diode is going to regulate the output voltage. It is going to be used as a voltage regulator. So it is used for a function of stabilization of voltage. So option C will be the right answer here, stabilization. So Zener diode is used for stabilization. So here Zener diode is used as a voltage regulator, that is for stabilization purpose. So here option C is the right answer, that is stabilization. Then we'll go to the next question. Question number 24. Which of the following arrangement of diodes represent reverse biasing? Now we know that a reverse bias is a phenomena where the anode is connected to a negative potential and cathode is connected to the positive potential. In other sense, we can say that cathode is more positive with respect to anode. So if you see here the options for, so option 1 shows that the anode part, this is the anode and this is the cathode. So anode is connected to plus 5 volt and cathode is connected to plus 2 volt. So this is forward bias. So if you see the option B here, anode and cathode, anode is connected to minus 2 volt and cathode is connected to ground. So minus 2 volt is negative and ground is 0 volt. So this is, we can take it as 0 volt. So here cathode is positive with respect to anode. So this is a reverse bias connection. If you see the third option, anode and cathode, anode is connected to plus 2 volt and cathode is connected to minus 2 volt. So this is again forward bias. If you see the fourth option, that is this is anode and this is cathode, here we can see the cathode is connected to plus 2 volt and anode is connected to plus 3 volt. So again this is also forward biased. Okay, so here option B, that is anode is minus 2 volt and cathode is ground, will be one which is providing reverse biasing. So here, which of the following arrangements of diode represents reverse biasing? So option B is the right answer. So here you can see option B is the right answer. Then we'll go to the next question. Question number 25. The operation performed by the circuit as shown in the figure. So here, if you see this figure, now here there are two inputs shown. This is input A and this is input B. The input is given to a NAND gate whose inputs are shorted. So this is a NAND gate, and here also we are having NAND gate. So here if A is given as input, the output of NAND gate, which is acting as NOT gate, here the output will be A bar, and here also B is the input and here the output will be B bar. And then we are having a NOR gate here, NOR gate. So here the output will be A bar plus B bar whole bar. This is nothing but according to Boolean algebra, A bar bar multiplied by B bar bar, which is nothing but A into B, which is the expression for AND gate. This is the expression for AND gate. So out of these options, option C, that is this AND gate, will be the correct answer. So the operation performed by the circuit as shown in the figure is AND gate. So here you can see option C is the right answer, AND gate. Then we'll go to the next question. Question number 26. In a PN junction, the width of depletion layer is, options are Option A, decreased with decrease in doping concentration. Option B, increased with increase in doping concentration. Option C, decreased with increase in doping concentration. And option D is independent of doping concentration. So we know that from the theory of p-n junction doping that whenever the p-n junction is doped heavily and when the doping is more, the width of the depletion layer will decrease. So here option C is the right answer. The width of the depletion layer decreases with increase in doping concentration. So here option C is the right answer. So here you can see option C is the right answer. Then we'll go to the next question, question number 27. Which of the following option is true for Zener diode? Options are highly doped p-n junction used in forward biased, weakly doped p-n junction used in reverse bias, weakly doped p-n junction used in forward bias, highly doped p-n junction used in reverse bias. Now we know that Zener diode is usually used in reverse bias and it is a highly doped p-n junction whose width of the depletion layer is less. So option D will be the right answer. It is a highly doped p-n junction used in reverse bias. So here you can see option D is the right answer. Then we'll go to next question, question number 28. For the diodes given in the figure, the forward bias diode is, which one is the forward bias diode? So here you can see this is anode of the diode, this is cathode of the diode. Anode is 10 volt and cathode is 15 volt. So for forward bias, the basic requirement is anode should be more positive with respect to cathode. Now in this case, anode is not more positive with respect to cathode, so this is reverse bias. If you see the second option, this is anode, this is cathode. Anode is 0 volt and cathode is 5 volt. So here also anode is not positive with respect to cathode, so this is also reverse bias. If you see the third option, this is minus 15 volt, this is minus 10 volt. So here also anode is not positive with respect to cathode, this is also reverse bias. Now here if you see anode cathode in the option D, anode is 0 volt and cathode is minus 10 volt. So anode is more positive with respect to cathode, so this is forward biased. So here option D is the right answer, which is forward biased. So here you can see option D is the right answer. Then we'll go to next question, question number 29. The circuit diagram shown here corresponds to which logic gate? Now here if you see, this is the voltage applied. This is the voltage applied. This is switch A and switch B, and this is the bulb. So when this voltage is applied, current is going to flow. Current is going to flow. Current is going to flow here also. So this is I1, and current is going to flow here also. This is I2. Now here, this current will flow, and here you can see I1 will be equal to 0 when these switches are open, and this full current will flow as I2 through the lamp, and the lamp will glow, and the lamp will glow. That means when the switches are open, the lamp is going to glow. So here if you see the truth table, A and B are the inputs and the lamp is the output, that is the bulb is the output. When A and B are not connected, they are open, so this is 0 0, this is the lamp is going to glow, that this is how, say we'll take it as logic 1. Now similarly, if you close one switch, if you close switch A and if you open switch B, still this current will not flow, still that current I1 will not flow, the whole current will flow as I2 through the lamp. So even this is 0 1, this will be 1. And similarly, even the switch B is closed and switch A is open. So if you take it as 1 0, the lamp is going to glow. Now the lamp will not glow only when these switches are closed. This switch is closed and this switch is also closed. So here in this line, the resistance of this line will be low as compared to this resistance of this line. So the full current will flow through this line. So I1 will be equal to I and I2 will be equal to 0. So lamp will not glow. So when both the inputs are 1 1, the lamp is 0. Now this is the truth table. Now this is the truth table for which gate? Now if you remember, this is a truth table for NAND gate. NAND gate. That is when both the inputs are high, the output is low. Otherwise, the output is high. Okay. So here, NAND gate will be the answer. When both the inputs are high, the output is low. So here, NAND gate will be the answer. That is option D is the correct answer. So here you can see option D is the right answer. Then we'll go to the next question. The current in ideal PN junction diode shown in the circuit is how much? Now here this circuit has this voltage source V1 and this voltage source V2. So the voltage across, that is voltage between the 2 points, is given as V1 minus V2. So here this one, so here you can see this is negative, this is positive, so this is taken as minus 1 volt, and here also this is negative and this is positive, this is taken as minus 3 volt. So the voltage difference, that is a potential difference, is minus 1 minus of minus 3, that is equal to minus 1 plus 3, that is equal to plus 2 volt. Plus 2 volt. Now the voltage is 2 volt, V is equal to 2 volt, a resistance given, R is equal to 100 ohms. So how much is the current which is going to flow through this? How much is the current which is going to flow through this? So here when we calculate the current I is equal to 2 volt upon 100 ohms. Okay, so this is nothing but 20 milliamperes. 20 milliamperes. So I is equal to 20 milliamperes, and here option C will be the right answer, that is 20 milliamperes. So here you can see option C is the right answer, that is 20 milliamperes. Thank you, students.